Hello, Year 7. Welcome to Week 4, Lesson 4. Today we're looking at revision of particles and their behavior. In this topic, we have looked at the following. We've looked at the particle model, states of matter, melting and freezing, boiling, sublimation and evaporation, diffusion, and gas pressure. Let's look at the first one, the particle model. Here are some definitions that you need to remember. Matter is something which takes up space. Particles, all matter is made up of particles. Particles are usually too small to see, and they may be atoms or molecules. The third one is materials. Different types of particles make up different materials. Pure substances. Some materials are made up of the same particles all the way through. These are called pure substances. And lastly, mixtures. Some materials are made up of different kinds of particles. These are called mixtures. If you see the diagram on your bottom right, you can see a mixture of particles of yellow, blue, and green beads. And at the bottom, you can see particles that represent pure substances because they are of the same type and there's no difference between them. The substance of a property describes what it looks like and how it behaves. The substance of a property depends on what the particles look like and their arrangement. There are three types of states of matter. Can you remember what they are? You can pause the video now and have a go. Can you remember how to draw the particle diagrams? Now in the picture you've got a solid, a liquid and gas particle diagrams. What are the properties of solids, liquids and gases? In a solid, the particles are rigid. They have a fixed shape, a fixed volume, and they cannot be squashed. The particles are all touching. So when you're doing particle diagrams, you have to make sure that they are all touching. In liquids, the particles are not rigid. They have no fixed shape. They don't have a fixed volume, which allows you to be able to pour them, and they cannot be squashed. And in gas, the particles are not rigid. They have no fixed shape or fixed volume, and these particles can be squashed. The third thing we looked at was melting and freezing. We looked at the change of states. Can you name the states when we go from a solid to a liquid and from a liquid to a solid? You should remember this. What is happening to the arrangement of the particles when you go from a solid to a liquid and vice versa? Looking at the diagram on the far left, you've got your particles arranged as a solid. They have the least amount of energy. In the middle, you have your liquid particles. They have a little bit more energy. The particles are touching, but they can exchange places with one another. With a solid, they cannot exchange. They cannot exchange places. And in gas particles, they have the most amount of energy because they are free to move, and they can move quite fast compared to solids and liquids. The particles are not touching one another. How can you tell if you have a pure substance? Pure substances have a sharp melting point. For example, we know that the melting point for ice is 0 degrees. So ice will melt at 0 degrees. If you add a substance to another substance to water, for example, what you will find is that the temperature will be a lot lower than at 0 degrees. So your water will not freeze at 0 degrees. This is something you can try at home if you've got a thermometer. Please ask an adult to help you because you don't want to break the thermometer and then hurt yourself in the process. So you can get some water, add some salt to it, maybe a teaspoon of salt to a glass of water, and mix it together and put it in the freezer. Check the temperature when it's 0 degrees and see whether it is a solid at that point in time. Boiling, sublimation, and evaporation. What are the differences? Boiling point is the temperature at which a substance changes from a liquid to a gas. A substance can become a gas by evaporating as well. Typical everyday examples. Someone's made a cup of tea. Obviously, when your tea is in a mug or in a cup and saucer, your tea is not at boiling point. So the gas particles are evaporating from the surface of your tea. Another example is when you wash your clothes. The clothes are not at boiling point, and yet the clothes get dry because water evaporates into a gas, allowing your clothes to dry. Other key processes we looked at sublimation. Sublimation is when you go straight from a solid to a gas. This process bypasses the liquid phase. And going from a gas to a solid is known as deposition. When you go from a gas to a liquid, that is known as condensation. So these are all the keywords that you have learned about in previous lessons. Diffusion. You did diffusion this week. Diffusion is the movement of particles from an area of high concentration to an area of low concentration. And you saw the practical that Miss Moore did. We also looked at gas pressure this week. Looking at the picture in front of you, what is wrong with this picture? If you said that no arrows were added to the diagram, then you're correct. No arrows showing the movement of particles. Whenever you're drawing gas particles to show that they are moving, you need to draw arrows, and they need to be drawn in a random way. So your picture should look like something on the left. The pressure of a gas is affected by what two things? Do you remember this from when we did the gas pressure lesson? What two things affect gas pressure? The number of particles and temperature. These things affect gas pressure. Okay, we've had a brief look at all the things that we've done under particles and their behavior. So we've looked at the particle model, states of matter, melting and freezing, boiling, sublimation and evaporation, diffusion, and gas pressure. You should now be ready for your assessment. You will need to go to SAM Learning for your assessment. So you need to log into SAM Learning. This is compulsory because we need to make a record of your results and make sure that you guys are making progress. The link will be added to the homework section on EduLink. Bye for now.